Good day, everyone. So, today we shall be diving into an interesting topic, and that is scalars and vectors. At the end of this lesson, we will be able to know what scalars and vectors are, their differences, and how the vector aspect can be added or subtracted. All right, so let's dive into this. So, when we talk about scalars are physical quantity in physics that have only single value, that is just magnitude only. You can only determine their size. You can't get their direction. So they are the kind of measurement that you take just in determining size or what we refer to as magnitude. But direction is not involved. What do I mean? Example of this kind of these scalars are mass, distance, and speed. For example, now talk about mass. We know that mass is the quantity of matter in the body. So, for example, I can say my mass is maybe 70 kilogram. So it doesn't matter whether it is being measured from the left to the right or from the top to the bottom. What matters is that the amount of matter in my body is 70 kilogram. Okay, so whenever you're not interested in the direction of that measurement, then we are talking about scalars. So we have a lot of examples of scalars. So mass is one of them. Then we also have distance, or what we refer to as length at times. Then we have speed, we have time, and so on. And we have potential, okay, we have temperature. So there are many of them. We have power, okay, we have work. So there are many of them that you're only interested in the value, one value, the size. You are not interested in the direction. So such quantity are referred to as scalars, or simply put, scalar quantity. All right. So I will say that. Now let's talk about more examples. Now I've mentioned mass. Let's go into detail about mass. Amount of matter or amount of substance in the body is called mass. It's measured in kilogram. Of course, in our last class we said it's also a fundamental quantity. So mass is measured in kilogram as its unit. So we can say 5 kilogram, for example, just magnitude. We are not interested whether the quantity of matter is measured from north to south. No. All right. So another example of scalar quantity or scalar is the distance. Okay. All right. We can say 10 meters. Can say 5 kilometers. Okay. As long as the unit is there, it's measured in meters or kilometers. You know that you are dealing with distance. You're not interested whether the distance is from A to B, in the north to south. No. What you are interested in, the distance between A and B or between B and A is 10 centimeters or 5 centimeters. That's all. Direction is not involved. The same thing applies to speed as another example of scalar quantity or scalar. Okay, speed is just the distance covered in 1 second. Okay, so it's distance over time. Okay, and it's measured in the SI unit of speed is meter per second. It has other unit as well, like kilometer per hour, and so on and so forth. But the point we are making here is that it does not involve direction. Time also does not have direction, right? It's just the magnitude only. So let's now talk about the other one, and that's the vector or vector quantities. So vectors or vector quantities have both magnitude and direction. In this type of quantity, you are not just interested in the size of the magnitude, you are also interested in the direction of that quantity. And some of the examples that we have are weight, because weight naturally is the earth pull on the body, and it usually measured from up downward, vertically downward. So the direction of weight is always vertically downward. Displacement is distance covered in a specific direction. Okay, so in this case, it's different from normal distance that we mentioned earlier. Normal distance is not interested in the direction, but displacement is a type of distance that is interested in the direction. Okay, so because it has a direction, it is also referred to as a vector quantity. The same goes to velocity. Velocity is distance, okay, per second in a specific direction as well. You know, speed is distance per second, okay, without direction. But velocity is not just distance now because it is involving direction. We will now say velocity is displacement per second. This time, displacement cover in 1 second, okay, because displacement is distance covered in a specific direction. So we can now say that velocity in a proper definition would be the displacement covered in 1 second. Then acceleration is the velocity covered in 1 second. So it's also a vector quantity or a vector. So these are some of the examples of vectors. We have other ones. Okay, we have force. Force also is an example of a vector quantity because it has magnitude and it has direction. So we have as many as you can mention. So we go straight to how you represent vector quantity. We use symbols and arrow to represent vector quantity. All right. Majorly, the arrow show you the direction, okay, while the line shows the magnitude. For example, now this vector C now has an arrow on it. It means that the line there is the size of the vector, while the arrow on it is the direction of the vector. So basically, the symbol to represent a vector is an arrow. Okay, so whenever you see an arrow, okay, having a letter underneath, you know that it is what? A vector representation. All right, so this is vector A. We can call this vector A. We can call this vector C. Okay, so now aside from representing vector with arrow, we also need to learn for today a simple way of either adding vectors or subtracting vectors. Now, how do you add vectors? Okay, let's quickly do a little mathematics here. Now, let's consider this. Maybe you have um, maybe you have a vector. A vector. Let's say we have a vector of 5. Okay, maybe that vector in this case, let's say the vector is a force. So a vector of 5 Newton. Okay, okay, along the right hand side, the right side. Now you have another vector, a vector, a vector 4 Newton along the right side too, and then you have to add these two vectors together. You are going to add two vectors that are on the same direction. What you need to do is just to do your normal addition. Just do your normal addition by saying 5 plus 4. And that is giving us 9 Newton. So the addition of vector on the same side, on the same direction, is just to add them up together. It's very simple. But another scenario where maybe this time around, let's say that the 4 Newton is in the opposite direction. Okay, let's say it's in opposite direction. Let's change it to the left hand side. All right, maybe this is on the left hand side. Now let's say along the left hand side, left hand side. Now, so in that case, for you to get there, for you to add, instead of adding this time around, you need to subtract. Okay, that will be 5 minus 4, and that will give us 1 Newton. So whenever vectors are in the opposite direction, you subtract. Whenever they are in the same direction, you add. That is the principle of vector addition and subtraction. You add when they are in the same direction, and you subtract when they are in the opposite direction. All right. So I won't say that. Let's solve more example from jam question. Now look at this question here. This question says, to determine the weight of an object, you could use a beam balance, use a spring balance, C, find the force necessary to give it a certain acceleration, D, use none of this method, E, use any of this method. Okay, let's examine it one by one. The first question we should ask ourselves is, what is the instrument to measure weight? Weight is a vector quantity, but the instrument you use to measure weight is called a spring balance. So to measure weight, you have to use a spring balance. So B is correct. Now let us consider option A, use a beam balance. A beam balance is used to measure mass. And mass is a scalar quantity or a scalar. So A cannot be correct. B is the correct option. C says find the force necessary to give it a certain acceleration. Because this is you're dealing with weight, okay, and weight formula, aside from the instrument, weight formula is mass times acceleration to gravity. So in this case now, this very option is not complete. Okay, it's not complete. Now this they use none of this method. D is not correct because we can use option B. And E say use any of this method. No, because we cannot use A, cannot use C. Okay, so this is 1978 JAM. Okay, the first year that JAM was written. So we have another question here, question 3. So which of the following physical quantity is not a vector? So it is very important that you should be able to know quantities that are vectors and those that are not vectors. Okay. Now we mentioned in our example before that velocity is an example of vector quantity. So we know that vector velocity is one of them. I mentioned work, that work is a scalar quantity. So work is not work is not a vector quantity. Okay, force is a vector quantity, and electric field intensity is a vector quantity. Magnetic induction is also a vector quantity. All right. So we also have another one. Say an example of a scalar quantity is velocity. No, because we have said it's a vector quantity. Weight. No, weight is a vector quantity. Electric charge. Yes, we didn't mention electric charge, but now you have seen it now. Add it to your archive that electric charge is a scalar quantity, while acceleration to gravity is a vector quantity. So the others are vector quantity except electric charge. Electric charge is a scalar quantity. Even momentum is also a vector quantity. So please take note of all of these vector. Now the question is, the quantities are so much. How do you distinguish them from uh, each from one another? Okay, how do you separate them to be either scalar or vector? Is practice. You cannot at a go know everything. Practice, practice, master them, and then you get to know them uh, later. Okay, all right. Now we have another question here. One of the following readings represent the measurement of the length of a metal rod using vernier caliper. All right. Now vernier caliper is one of the instruments that you use to measure length. Aside from your meter rule, okay, you can also use vernier caliper to measure length. We use micrometer screw gauge as well to measure length. Okay, aha. So taking the reading accuracy into consideration, the most likely one is 5.16, 5.165 centimeter, 5.0 centimeter, 5.160 centimeter, 5 centimeter. Now the, the, the secret here is when it comes to vernier caliper as an instrument, it always allows you to measure your object and leave your answer in two decimal places. So among all of these options here, check the one that has two decimal places. Okay, two places. If one that is option A has 5.16. Whenever it is vernier caliper, you know that your answer should be in two decimal places. Okay. If it is meter rule, it will be in one decimal place. Okay, so automatically from all the options here, it's only option A that is in two decimal places. So we don't have to rack your brain. is just 5.16 centimeters. All right, because we need to talk about it because length is also a scalar quantity. In fact, all the fundamental quantities that we discussed in our last lesson are all scalar quantities. Now, we have this here. So which of the following is not a vector quantity? Okay, so in this case, it's the reverse of this one. All right, so we have force, altitude, weight, displacement, acceleration. Okay, another way you can easily handle question like this is check out for the one that you are aware of. Okay, you know that force is a vector quantity. Okay, you know that weight is a vector quantity. So those A and C are knocked out like that. You are looking for those that are not vector quantity. We've said, we also say that displacement is a vector quantity. Acceleration is a vector quantity. So definitely altitude is not a vector quantity. So our option here is altitude. Altitude is just height. When you're measuring height, is a synonym for height. All right. So we also have another question here. It said of the following derived unit, the one that is not a unit of power is what? Now, before you can know the unit of power, you must also know the formula for power. Okay, power, by the way, is another example of a scalar quantity. Okay, now power by formula is work over time or energy over time. Now you know that work is measured in joule, time is measured in seconds. So definitely option A is correct because it's joule per second or joule per second. So option A is one of the unit of power. Now we have B, which is ampere volt. Ampere is the unit of time. Volt is the unit of potential difference. Could that be correct? Okay, let's go on and check. Now we also have ampere square volt. Now, when it comes to electrical power too, this does not apply. Electrical power, we have formula for electrical power. We have one of the formula to be current times voltage. Okay, current times voltage. So B is correct because ampere represent current, volts represent voltage. So B is correct, A is correct. All right. So we have seen that to be correct. Now let's now quickly break it down. Let's break it down a little or to understand this. So we say here that power is electrical power. Electrical power by formula we say is P is equal to IV. That is power is equal to current times voltage, right? Now we've confirmed A and B. A and B are correct. Now we want to confirm ampere squared times voltage. Could that be correct too? Okay, let's find out. We also know that V itself is IR. So if we substitute the value of V into this place, we'll be having our P to be I squared R, right? So when you substitute the value of V to this, so it will be I squared R. So I squared means ampere squared, then R means ohms. Okay, so ampere squared ohms is not in our option. We have ampere square volt. We have ampere square volt. Okay, so we are not. The option C is not in our option. Then we also have ohm square volt. Now let us also work it out. Now when you are dealing with exam, you have to be very fast. Now here we have P is equal to I square. Now applying this again, remember that we said P is equal to IV. P is equal to IV. Now if we come here now and make your I subject to the formula here, your I here will be equal to V over R. Now bringing the value of I back to this place, you'll be having your P to be equal to V squared over R. So here we can also say it is volt squared over ohms. Volt squared over ohms. So that means this one is option E is correct. Option B is correct. Option Option A, we have verified that is correct as well. So we are left with option we are left with option D and option C. Now, option D is ohm square over volt. Ohm square over volt. Do we have anything like ohm square over volt? Let us find out how that works. That is telling you that it is R square over V. R square over V. Let us find out how this is correct. This does not exist. This does not exist actually, but this can be verified. I square I square V. I square V. We have something like I square. That we are telling us that power is equal to I square V. I square V. Is there anything like I square V? No. What we have is I square R. I square R. Okay, so the one that is not a unit of power are option C and option D. Okay, option C and option D. Okay, so we shall be drawing the curtain here today. I hope that you have learned something today. Thank you for listening and have a wonderful day. Bye for now.